okay, and this will give you more accuracy as well because the error is least. See, it comes here, so you can from here again you can go for that and then number it 1 2 3 4 5 6 7 8 9 10 and 1 2 3 4 5 6 7 8 9 10. Good, that is good. Should always use it this for dividing. Good, that's good. Okay, now we have numbered. Just keep your hair at the back so that the cameras are visible. Okay. So the divisions can be more as well. The more the number of divisions, the more accurate will be your drawing. So once we are done with that, now what we will do is we will join 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash. Now these all lines will be the actual tangents of the curve that we are trying to draw, which is parabola. Okay, Mr. Vipin has finished. Good. Okay, so on the screen the animated description is shown for the viewers. Okay, give the dimensions. Rub this line. Okay, let it be there. It's okay. Okay, so that is good. Now the final step, we have to draw a smooth curve which touches all these lines, because you know what is a tangent. Tangent is a line, a straight line which touches a curve at a single point. So we are drawing a parabola or a simple curve which is touching each and every line at only one point, so we get the basic parabola that is required. Yes, the measurements, don't forget to mention the measurements, because if you are not mentioning the measurement, it is not engineering drawing. It is just a graphical representation of something you want to show it on paper. It is not engineering drawing at all. Okay, so this is the final solution that we are looking for, neat and tidy. Always remember that in any engineering paper, when engineering graphics paper, when a assessor is assessing, they always look for neatness as one of the first priorities, because that is the first impression that your drawing puts on the paper checker. So please try to maintain maximum clarity or maximum neatness on your paper. Done. So let's move to the directrix and focus method of the parabola. Now for directrix and focus method, we know that for parabola the eccentricity is equal to 1. Okay, for when eccentricity is equal to 1, that means the distance of that point from the focus and from the directrix is equal. That is what it means, that the distance of any point on parabola is equal from the focus and from the directrix. Okay, now here we will take the focus as 70 mm and we know that eccentricity is equal to 1. So if in the question you have been told to draw a parabola and eccentricity is not mentioned, then don't get hyper, because eccentricity is assumed to be 1, it is 1, so you have to assume it to be 1. Now the first will be always, when in directrix and focus method, the first step is always to draw a directrix, and which is a vertical line, and an axis CC dash which is horizontal to that, perpendicular to that directrix, as shown on your screen right now. The AB is the directrix and CC dash is the basic axis that we are seeing here. Okay, the next step, drawn the directrix and label it. Done with the labeling part. Okay. Yes. Now mark the focus, that is 70 mm from the directrix. So we will mark F on C dash with using our protector, using this, not the scale. Okay. CF is equal to 70. So we have cut an arc here, and then this is the 70 mm and CF is the focal length, or F is the focus. Now next step, mark midpoint of CF. Why we are marking the midpoint of CF? Why we are marking the midpoint of CF? Because eccentricity is 1, we are having equal parts, so we are dividing it into half, and the midpoint of CF will be equal to V. That is the point from where the curve will be passing. So V is one of the points on the parabola. Okay. Now, yes, we have seen on the animated thing that this is V. Now the next step is mark points 1, 2, 7 or even more on the axis C dash, starting with V on equal distances. If you are taking 5 mm, then take 5 mm on all points. If you are taking, this measurement should be outside the figure, not within the figure. You should always remember, any measurements that you keep should be outside the figure and not within the figure. If you are marking it within the figure, then please follow the standard notations for those particular notations or markings. So once you have divided it into equal parts, 1, 2, 3, 4, 5, 6 and 7, starting with V. Now the next step would be to draw perpendiculars from 1 to 7. Draw perpendicular lines from 1 to 7. These lines will be parallel to the directrix. These are just free lines which are parallel to the directrix, passing through point 1, 2, 3, 4 up till 7. At V we need not draw the parallel lines, because V will be the point from where the tangent will pass, because it is the point on the circle, on the parabola. Okay. Now with F as center, keeping F as center and radius equal to C to 1, with F as center and radius equal to C to 1, cut an arc on the line passing through 1 at P, and yes, cut here and cut there, mark this as P and mark this as P dash, and repeat the same procedure for 2, 3, 4, 5, 6 and 7 on the screen. For the viewers on the screen, the animated presentation is being made. Try to maintain maximum clarity and use very light hand while drawing these kind of figures, because the major is the curve which should come up. Major is the curve that should come up. Yes, it's okay, you can, those are enough. Yeah, duplication of lines should be avoided. Now the final step is, once you have all the points, then the final step is to draw a smooth curve passing through each and every single point that you have got. And once you make a curve, then this is V should be the point from which it should pass, from P1, P2, P3, P4, P5 and up till this. So the required curve is obtained when we join this all in one line, starting from here. Yeah, that is good. Try to make the curve as smooth as possible. No, we have not marked the points. You have not. After this, you have to give the measurements. F, where is V? This is measurement. This measurement. Done. Write down the measurements. From here to this is where you can mark V, and this is, and there only you can. This is the horizontal out of the figure. From here to V, from here to focus. Just measure it and keep it. Yeah. So construction of hyperbola, we'll take it in the next session. Once we are done up with this. Okay. So this is the final figure of the question that was given for the parabola. So these were the 4 different methods of making a parabola. So for hyperbola, we will join you in the next session, and that will be an hour-long session, and we'll be covering up the rest of the curves in that. Thank you.